Well, here we go again. I'm still trying to find the right combination of parts to replace my venerable old Epyc 7402, which died a couple of weeks ago. Today, we're going to talk about doing something that I said could not be done. Building a server around an AM5 consumer-grade chip. We're going to pair the AMD Ryzen 9950X with the ASUS ProArt X870E motherboard. We're going to discuss the intricacies of PCIe switching and how best to configure devices on this board to take advantage of the somewhat limited PCIe lanes available. So let's start by taking a look at the CPU first of all. This is the Ryzen 9 9950X, the AMD Ryzen chip, and this is the flagship, or at least it was until a couple of weeks ago, of the Zen 5 lineup from AMD. Technically now, the flagship crown goes to the 9950X3D instead. But make no mistake, the 9950X non-3D is still a fast chip. 16 cores and 32 threads with a base clock of 4.3 GHz, turboing up to 5.7 GHz. This chip is at the cutting edge in the desktop space, and it provides 28 PCIe Gen 5 lanes into the AM5 socket. It tops the charts in almost every single test for sheer multi-threaded performance, with only really the 9800X3D and now the 9950X3D really being able to beat it in synthetic benchmarks. Built on TSMC's 4nm N4P processing node, the 9950X uses two 8-core CCDs with no cores disabled, and each CCD on this thing provides 32 megs of shared L3 cache to each half of that CCD. It's got a TDP of 170 watts and is configurable all the way up to 230 watts using AMD's Precision Boost technology, or PBO. This is AMD's advanced auto overclocking utility that allows the processor to exceed its standard power and thermal limits only if there's adequate cooling available. At the time of recording, the 9950X is available for about $500. I paid $520 for this one on the desk in front of me. And the 9950X3D, which is essentially the same chip, but it has a much larger 3D V cache, which is best suited for things like gaming, can be found for about $750, if you can even find one in stock. To me though, the price delta isn't really worth it because for a server type application at least, you know, unless you're building something like a 7 gamers, 1 CPU, or you're just going to build a server that's just doing gaming GPU pass-through, where that extra little bit of performance and, you know, latency improvement might be worth it, that $200 to $250 price delta between the 9950X and the X3D is not really worth it in my opinion. The Zen 5 parts compare pretty well against older hardware, as you can see in this chart, and what was considered fast just a few years ago, the i7-8700K from Intel, is almost 400% slower than this new chip. And every attribute across the board, it's a similar story. CPUs sure have come a long way. Now, the 9950X is a dual CCD part, as I mentioned, and this means that AMD stitches together essentially two chiplets to form one CPU. Historically, this split has caused some huge latency spikes for gamers looking for the absolute fastest chips, and as OS schedulers placed workloads straddling these CCDs, it can cause issues and latency spikes, and for gaming at least, you would notice that in frame drops and stutters and pauses and things like that. However, in a server application where we can pin VMs to specific cores, or indeed pin them to specific cores on specific CCDs, our workloads are just not that sensitive to those kinds of micro stutters, and probably are going to be much more multi-threaded than your typical video game or desktop type workload. And so spreading a single chip across two chiplets inside is much less of an issue. Idle power draw is possibly the only real criticism to be levied against this chip, to be honest. Compared to Intel, at least, a modern Intel chip with the P and E core layouts can easily idle in the single digits, whereas this chip sits around 30 to 40 watts, I'm afraid. However, under load, the story is reversed. The Intel chips suck down the juice when you're pushing them, versus this one, which is more efficient when you're pushing it. So you win some, you lose some, I guess. So this 9950X chip kind of has it all really, at least on paper. Extremely fast single-threaded performance, class-leading in fact, good energy efficiency, ish. I mean, depends how much of a workload you're actually going to give this server. If it's just sat at idle all day, well, first of all, why are you putting this chip in there? And secondly, at idle, it pulls a little bit more than I would like. So it's got good fast single thread performance. It's got decent power efficiency under load. It's got a lot of multi-thread headroom too. But what about the PCIe lanes? This is where it gets a little bit more complicated, I'm afraid, because there are only 28 PCIe lanes available on consumer platforms. Now, the X870E ships with an extra chip, which we'll get to in a minute, that gives you a few extra lanes. But in my last few videos, I've been going through the motions migrating from an Epyc 7402 with 128 PCIe lanes to the Threadripper Pro again with another 128 lanes. But for a few reasons, detailed in this video up here, it didn't quite work out for me, the Threadripper Pro that is. So here we are with the 9950X and its paltry 28 PCIe lanes. So what is a PCIe lane and why does Alex keep going on about the damn things? Well, your GPU typically asks for 16 lanes. You've seen that on many PCIe slots, I'm sure, in your time of 16X. That's what it means. It's got 16 direct electrical connections back to the CPU socket. An NVMe SSD, perhaps, might request 4 lanes, and sometimes 8 depending on the situation, but most of the time it's 4 lanes. So you start adding that up, and across a whole server, you can see pretty quickly, by the time you've got, I don't know, half a dozen SSDs in there and a couple of graphics cards, 28 lanes just is barely adequate if you can make do with it. The X870E is the top-of-the-line chipset for the AM5 range from AMD today. The E gives you an extra chipset, so you can think of X870E for extra. It gives you an extra chipset on the board, which gives you an extra magical 12 PCIe lanes. 4, by the way, are stolen from the CPU to wire in that extra chip. But overall, you gain 12 extra lanes on the E variant. On the motherboard we're looking at today, the ASUS ProArt X870E, that means we have 40 lanes in total to play with. Now remember, this has to cover all of our NVMe devices, SSDs, GPUs, 10 gig networking, and any other devices we want to connect. Now I know, Alex, 40 is not 128. Thank you, Captain Obvious. But 40 is workable if we make some compromises. And in my case, with some careful planning and experimentation, I believe I can do almost everything with this AM5 based system versus the older, more expensive Threadripper Pro and the Epyc box. And if I can't, well, this setup is half the price. I can literally build 2 of these top-of-the-line systems for the price of 1 Threadripper box. And so for me, just that price calculation was enough to pull this out. This has been my gaming rig for the past few months. And for the last few days, since I decided that the Threadripper Pro and I were going to part company, I've been really thinking about, do I need 128 lanes? Sure, it's nice, but I could probably make do with just the 40 on offer here if I'm willing to make a couple of compromises. So before we get into that, let's take a closer look at the ASUS ProArt X870E motherboard. This is an ATX size board, no gargantuan E-ATX stuff here. It's a top-of-the-line board, premium stuff here, chaps. It can house up to 256 gigabytes of DDR5 memory, including ECC support, by the way, and supports up to 8,000 mega transfers per second RAM using the AMD Expo feature in the BIOS. There are 4 M.2 slots on this board, although we'll get onto why the intricacies of PCI switching mean that really, in reality, there's only 3 slots available for us to use. And this slot here, I should point out as well, is a Gen 5 M.2 PCIe slot and is extremely fast. There are 4 SATA 3 ports on board and 10 gig networking is provided via a Marvel controller in the RJ45 format again. I would love to see SFP Plus on a motherboard, but I think I'm barking up the wrong tree with that one. And next to that 10 gig NIC is also an i226 2.5 gigabit NIC from Intel as well. No IPMI on this board, but these days with the Jet KVMs, the Nano KVMs and the Pi KVMs, that's not really that big of a deal, and I wouldn't really expect it from a desktop class motherboard either. Now, should you want Wi-Fi in a server, it's here. It's present in the form of Wi-Fi 7, along with Bluetooth 5.4. There are, as you might expect from a high-end AM5 platform motherboard these days, lots of USB ports available, fast ones too, including a pair of 40 gigabit USB-C USB 4 ports. Now, don't call them Thunderbolt because that's an Intel brand. No, they definitely aren't Thunderbolt. But chances are, if you have a Thunderbolt peripheral and plug it into one of those USB 4 ports, it's about 95% certain that it will just work just fine. Now, the build quality of this board, as I say, feels top tier. It's a really nice thick PCB. It just feels well made, at least to look at. Huge hefty heat sinks provide a real chunk to this thing, and there are some questions and concerns online about the 10 gig NIC overheating or randomly dying. In fact, when this was my gaming rig in that box over there behind me, I did experience a couple of dropouts during long gaming sessions, but that's when the GPU was in the top slot. So I moved the GPU down to the second slot and alleviated this issue altogether. So that's just something to be aware of. Make sure it's got adequate cooling, and I think you should be okay with the 10 gig NIC that's on board. Now, when talking about PCIe layout, this is where I need to absolutely maximize what I can get from these limited 40 lanes. And it took me some experimentation this weekend to find a combination that did exactly what I needed. Now, the ASUS BIOS does support bifurcation. That's the process of splitting up a single 16x PCIe port into multiple ports electrically. So it takes that 16x slot here and slices it up into 4x4x4x4 or 8x8 or any permutation thereof, at least kind of. The way the internal PCIe switching on this board is wired means that there are only really a couple of options available when it comes to bifurcation at all. The manual goes over this in great detail, but I found it very confusing the way that ASUS kind of laid it out, but I got there in the end. So what I did was I figured out that slot 1 was a 16x slot, and that can be configured to be in a 4x4x4 by 4, so 4 times 4 effectively, split up using one of those ASUS Hyper M.2 cards. So you can effectively put 4 M.2 SSDs into that top slot. Excellent. However, if you then populate the second PCIe slot, this one down here, slot 1 switches to become an 8x slot, unless you have something in the M.2 by 2 slot, this one here. And then this one becomes a 4 by slot. And then the final slot is, even though it's a 16x mechanical slot, it's only wired up as a 4x slot. Confused? So was I. So let's run through that once more. Slot 1, I've bifurcated this into a pair of 4x4 lanes so that I can put in this. This is a pair of Intel data center SSDs, U.2 NVMe SSDs. These run fairly warm, but they are so incredibly performant and just, you know, solid, reliable data center SSDs. These are the Intel DC P4510, and each of these is 4 terabytes. So between this, obviously, 8 terabytes, but I'm going to run these in a ZFS mirror and use this as kind of the backing store for all of my virtual machines, as well as a few other things on this server. So that's the first slot taken care of. The second slot is going to be home for this GPU. This is the NVIDIA A4000, and I like this thing in a server because, well, look at it. It's tiny. It's a single slot card that only takes a single 6-pin input, runs at 140 watts under maximum load, and I put this in the second slot down here, and it runs at 8x speed, which is plenty for all the machine learning, Ollama, image, face processing stuff that I want to do. And this does the trick just fine in the second slot. And then in the third slot, I have this guy. This is a really pretty old 4-port SATA card that runs at 4x speed. And this allows me to have, well, I've got 2 pairs of SATA 3 ports, so 4 ports on the motherboard and 4 more here. You could just as easily throw in an HBA card that has a single SFF port and break that out instead if you wanted to. Or indeed, put one of these cards in instead, which I'm not going to, even though it's got a 16x looking slot on here. You could run this NVMe SSD in that bottom slot to make up for this one disappearing at 4x speed. So lots of options with this board, but once it's full, it's full. It's not like the Threadripper platform where you've got 7 slots to play with. You've basically really only got a couple, and even those are only 8x slots. So some compromises do have to be made, but I do think that for most people who aren't trying to completely over-engineer their home lab servers, this will probably do for most people. Now, the manual does an okay job at making this clear, but it really could be a little less confusingly worded. I mean, they've got some tables in there, which I'll put up on the screen right now, that sort of show you all the different permutations. But the reality is you're going to have to make some compromises for a desktop platform versus a server platform. In my case, coming from the exceedingly generously over-provisioned Epyc server and Threadripper Pro, I have had to forego a couple of M.2 SSDs, woe is me, I know, to make everything fit. It's not a huge deal because I'm going to let some of the tasks that the box did before run over onto other systems. More on this in future videos, I suspect, on the channel, but it's worth noting that the configuration here doesn't feel particularly opulent, and yet it's completely maxed out. Like, I think if a consumer platform was able to get to the region of, I don't know, 50 or 60 lanes, and then the bifurcation in the BIOS was there to support it as well, that would really just take the pressure off. But it is what it is, so I should stop complaining. Now, let's talk about power usage, and that's been pretty decent throughout my testing. I can confirm that the system at idle draws around 80 watts running Proxmox with all of this hardware installed, like the NVIDIA A4000 GPU, a pair of U.2 NVMe SSDs, and the 3 NVMe SSDs on the motherboard itself. Under load, I can push this up to about 400 watts, but even that's very, very reasonable for what's on offer here, to be honest. If you consider the amount of performance available in this 9950X chip, this is really a very powerful platform. And compared to the Threadripper Pro at least, Proxmox just boots. No special kernel flags required or any weird hacking of BIOSes or anything, it just worked. There really is a lot to like about this combo, and barring any major mishaps as I build the system over the next few days, this is going to be my primary compute node in my home lab Proxmox cluster. So keep an eye out on the channel for upcoming videos about configuring the software side of this system and how it's all going to fit together in my, melange of home lab systems that I have going on right now. Hopefully I can convert this room back from a chaotic mess of 15 computers that have exploded everywhere. But that'll do us for today, folks. Thank you for joining me for a quick review of the 9950X paired with the X870E as a home lab server. Thank you so much for watching, and until next time, I've been Alex from KTZ Systems.